Hello everyone, my name is Karan Mashru. Welcome to the video. So in this video, we are going to look at the solution of the problem, that is reach nth point. First of all, let us start by understanding the question. What does question say? There are n points on the road. You can step ahead by 1 or 2 steps. If you start from point 0 and can only move from point I to point I plus 1 after taking a step of length 1, find the number of ways you can reach at point n. So basically there are n points on the road and you are currently on point 0, okay, and there are n points from 1 to n and you want to reach to point n, and in every step you can either take a step of size 1 or step of size 2. So total how many different ways are there to reach point n, that is asked in the question. For example, for n equals to 4 the number of output is 5, for n equals to 5 the number of ways is 8. You don't need to read or print anything. Your task is to complete the function nth point, which takes n as an input parameter and returns the total number of ways modulo 10 to the power 9 plus 7 to reach the nth point. The expected time complexity is big O of n and expected space complexity is also big O of n. So if we now think about solving this problem, so what it is basically trying to say is, let's say my n value is 4, okay, so it is trying to say that there are 4 points on the road, 1, 2, 3, 4, and you are currently at position number 0 and you want to reach to point number n, that is 4 in this case, and in every step you can either move by 1 step ahead or 2 step ahead. So initially you are here, so you can either go here or either go here, okay. Now from here you can either go to 2 or either go to 3, because again you can take 2 steps from here, you can go to here or you can go to here, right? Now from 2 you can go to here or you can go to here, okay. So from here you can go to here or you can go to here, and from 3 you can come here or go to 5, but there is no 5. So how many ways are there to reach 4? Okay, so if we look here, so one way is what? 0 to 1, 1 to 2, 2 to 3 and 3 to 4. You take all steps of size 1. Another is 0 to 1, 1 to 2 and 2 to 4. The last step you take of size 2. Another is 0 to 1, 1 to 3 and 3 to 4. This step you take of size 2. Another is 0 to 2, 2 to 3 and 3 to 4. You take a step of size 2, then 1, 1. Another is you go from 0 to 2 and 2 to 4. You take 2 steps of size 2 each. So total there are 5 number of ways. So this is what it is asked in the question. So what can be the brute force approach? See, brute force approach can be just to recursively call all the possible ways, okay. So let's say I want, let's say I call a function n, which basically returns me number of ways to reach point n from point 0. Now you think in this way, what could have been the last step? Means let's say I want to reach 4. What could have been the last step? At every step I can either take a step of size 1 or size 2. So in all the possible ways, the last step could have been either from 3 to 4 or 2 to 4. Last step means I am at point number n. Now I can take a step of size 1 or a step of size 2. So either I could have come from 3 to 4 or from 2 to 4. You can see here 3 to 4, 2 to 4, 3 to 4, 3 to 4, 2 to 4. Right? So number of ways to reach n, I can say it is nothing but number of ways to reach n minus 1 plus number of ways to reach n minus 2. Because the number of ways I can reach n minus 1, from all those ways I can take a step of size 1 and reach n, and the number of ways in which I can reach n minus 2, point n minus 2, from there I can take a step of size 2 and reach here. So number of ways to reach n is equal to number of ways to reach n minus 1 plus number of ways to reach n minus 2. Now number of ways to reach n minus 1 is number of ways to reach n minus 2 plus number of ways to reach n minus 3, right? And number of ways to reach n minus 2 is equals to number of ways to reach n minus 3 plus number of ways to reach n minus 4, right? And so on, it will keep on going. When will we stop? When the base case arrives, f of 0 will be equal to 1, and I can also say f of 1 equals to 1, because I am already at the 0th step. So there is one way, like just stay there, okay. You cannot say it is 0 way, and f of 1 is 1. In order to reach at point 1, there is only one way. You move from 0 to 1, right? So whenever you reach f of 0 or f of 1, you return 1, okay, and in this way you will get f of n. But this will give you exponential time complexity because it is recurring, right? and this will give you time limit exceeded, so you need to think of something more efficient. Now the time limit in this brute force is exponential. We want to convert it into polynomial. So can we think of dynamic programming? If there are overlapping sub problems, then we can think of dynamic programming. Are there any overlapping sub problems? See here, I am calculating f of n minus 3. What is overlapping sub problems? If you calculate the same sub problem again and again, then they are said to be overlapping sub problems. Here also f of n minus 3 is calculated. Here also f of n minus 3 is calculated. Here f of n minus 2 is calculated. Here also it is calculated. So these are overlapping. So I can think of dynamic programming. Let us think of bottom-up approach in dynamic programming. So let us take a table of DP and let's fill it. Now what will be the dimension of DP table? Here I am taking only one parameter in the recursion table. So I can take one DP table of size n plus 1, where dp of I will denote the number of ways to reach from point 0 to point I using either 1 or 2 steps every time, right? Now I need to fill this. So first of all, I need to fill the base case. So I can say dp of 0 equals to dp of 1 equals to 1. There is only one way to reach point 1, right? Now how can I fill the remaining elements? I can say for I equals to 2, I is less than equal to n, I plus plus dp of I is equals to what? F of n is equals to what? F of n minus 1 plus f of n minus 2. So I can say dp of I is equals to dp of I minus 1 plus dp of I minus 2. And at every step we have to take modulo mod. So I'll take modulo mod. Mod value is 10 to the power 9 plus 7. So all the dpi values will be calculated, and after coming out of the for loop, I can return dp of n, that is nothing but the number of ways to reach to point n from starting from point 0. What will be the time complexity of this? The time complexity of this will be big O of n, because there is only one for loop. What will be the auxiliary space? It will also be big O of n, because I am taking a dp table of size n. Now let's look at its actual code. So if we look at the actual code, so I have taken one dp table, I have taken one I to iterate, I have taken the mod value dp of 0 equals to dp of 1 equals to 1, and for I equals to 2 to n, dp of I equals to dp of I minus 1 plus dp of I minus 2 modulo mod, and finally I'll return dp of n. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you.